alert notifications on.
Hello, welcome to another episode of What's Up with the Universe. I'm your host, Eli Who? That's me. And here we are going to be talking about Hubble Telescope. Yes. Lately, James Webb Telescope has been getting all the headline news, but people forget there's another telescope up in the sky orbiting Earth called the Hubble. I mean, basically, so we got to ask ourselves, why a space telescope? Well, there's many reasons why we need a space telescope. I mean, Hubble was designed as a general purpose observatory, meant to explore the universe in visible, ultraviolet, and infrared wavelengths. Sorry. The Hubble Space Telescope is a legendary automatic observatory in Earth's orbit, of course. It was our first major optical telescope. It was launched into Earth's orbit in April 24th, 1990. Yeah, that means it's old. Excuse me. The Hubble telescope has made over 1.5 million observations since its launch in 1990, capturing many objects such as the Eagle Nebula and protruding data that has been featured in almost 18,000 scientific articles to date. I mean, this telescope has studied more than 40,000 cosmic objects, providing astronomers views that we're unable to capture from the ground. I mean, in addition to blocking certain wavelengths of light altogether, Earth's atmosphere is made up of shifting pockets of air that cause a twinkling appearance of the stars in the night sky. This motion blurs the capture by telescopes on the ground. So Hubble was placed into orbit above the atmosphere to avoid these effects. See, when Hubble was first launched, many members of the astronomy community doubted its ability to observe distant galaxies, like John Bacall. He's one of the world's top astrophysicists and Hubble's advocate. He co-wrote a science paper in 1990 arguing that Hubble wouldn't reveal any galaxies not already visible from ground-based methods. Of course, history played out a little bit differently. I mean, in 1994, Robert Williams, who was the director of the Space Telescope, I'm not going to use acronyms, okay? He was director of the Space Telescope Scientist Institute in Baltimore, Maryland. He developed an interest in Hubble's ability to observe distant objects when he witnessed exposures taken in May and June by the Wide Field and Planetary Camera. Okay, it's the WFPC2. A high-resolution camera capable of capturing images over a wide field of view and wavelengths. The data itself showed a cosmic zoo of objects, suggesting that another deep exposure could reveal unknown parts of the universe. I mean, it's been over 25 years. Williams controlled 10% of Hubble's observation time, known as the director's discretionary time. He decided to use some of that time to take a long exposure. Of course, that would be made immediately available instead of waiting for the similar proposal to come and go through a lengthy approval process. No, let's just have no restriction on data and be able to release the data to the public as soon as we get it. Of course, after this decision, he created a team at the Space Telescope Science Institute for nearly a year of preparation, working to find the right location in the sky and taking test exposures to confirm the area they chose was free of large galaxy clusters. I mean, the Hubble's mirror is much smaller than those found in general-based telescopes, observatories. The telescope's unique position above Earth's atmosphere gives it incredible clarity. I mean, as the telescopes orbit Earth, its mirror gathers light from the cosmos, collecting images and data. For some of the Hubble's deepest images, the telescope has stared at some point in the sky for days, trying to capture as much as a dim glow of the faintest part of our known universe. I mean, when cosmic revelations here, when Hubble was launched, the age of the universe was known to be about somewhere between 10 to 20 billion years old. By examining a certain class of stars that can be used to define distance, Hubble was able to help narrow that broad figure down to approximately 13.8 billion years. It's now the base number that's used to understand the timeline of stars, galaxies, and more. The NGC 3147 is a star galaxy. It's one of our closest neighbors. It's only about 130 million light years away from Earth. You can see right here, Hubble's clear view of the cosmos enables it to capture details like the cluster of young blue stars, pinkish nebulas, lanes and lanes of dust visible in the galaxy's graceful, windful gowns. Hubble has actually uncovered supermassive black holes lurking in the heart of galaxies, and also helped map the presence of elusive dark matter around galaxy clusters. For example, RS Puppis is a cephalid variable star. Its brightening and dimming is a predictable wave over time. Using the brightness of cephalid variables, astronomers are able to determine distances to these stars. Of course, one of the strangest discoveries was one of the biggest revelations of the expansive universe is speeding up, driven by the presence of still identified and previously unknown quote-unquote dark energy. With its ability to bring precise images of the universe to Earth, Hubble has often shown humanity how much it has still to learn about our known universe and our cosmos. Hubble is itself a time machine. Space. It's so immense that it takes even light considerable time to travel the vast expanses between objects. Okay, let's take the Earth's moon, for example. It takes about 1.3 light seconds to reach us. So when we look up the moon in the night sky, we're actually looking as it appeared 1.3 seconds ago. The light from most distant cosmic objects began traveling through space billions of years ago. But when it finally arrived in our corner of the universe, it shows us that this universe as it was in the distant past. By capturing the faint light of the early universe, Hubble can see galaxies as they were billions of years ago, showing us just exactly how galaxies developed and evolved over time. We can't watch galaxies as the stars change. They evolve over a time scale of millions and billions of years. But viewing them at different stages of their existence, Hubble has helped demonstrate how galaxies change and grow through interactions and collisions. It's given us snapshots of stars at different shapes, stellar stages of life, and it's also shown them consolidating and igniting in clouds of gas and dust, breathing out layers and layers of nebulas, exploding as supernovae. I got this image right here. This is one of my favorite images. This is the Hubble Extreme Deep Field. This image contains approximately 5,550 galaxies, including some of them that go back as far as 13.2 billion years in time. But stars is not the only thing that Hubble has captured. Planets. It's been used to probe everything from the weather on planets in the solar system. Yes, I did say probe. To the birth of planets around other stars. It's examined the composition of atmospheres of these planets, or exoplanets, as many have captured one of the first visible light images of such a planet. Hubble's ringside seat to cosmic events. It's made essential witness to events in our own solar system, such as comets and asteroid impacts on Jupiter, like the Shoemaker-Levy comet. It's made observations of passing comets. Our cosmic backyard still holds many surprises. And Hubble has found rings and moons around Uranus, moons around Pluto, a ring around Jupiter. And because of Hubble, we have so much understanding of what our solar system truly looks like and basically how our own neighborhood actually works. Okay, that's funny. Oh, I hit the wrong button. Yeah. Sorry, that was a funny joke. What did the astronauts that repaired or serviced the Hubble telescope treat themselves after the spacewalks? Bubble gum. I think Mike Massimino would appreciate the joke. I'm gonna copy that one later and tweet it to Mike Massimino. Well, speaking of comets, like I said, Shoemaker-Levy, Hubble also detected another comet, Comet C-2014 UN 271. It's a Bernardini Bernstein. It's currently in the constellation of, I'm going to pronounce it correctly, Horologium. Horologium. Okay, sorry. The current brightest section of the comet is 2 hours, 33 minutes, 25 seconds, and the declination is minus 53 degrees, 26 by 40. Okay, just in case you guys want to know. The central coordinates basically Greenwich Unit time. That's another discovery I just information has on these guys. Did you know that? Oh, I'm not gonna read that, dude. Too many bad jokes, but the first one was funny. Okay. The Hubble Deep Field. The image holds about 342 separate exposures taken between December 18th and the 20th of 1995. The picture we saw was basically assembled from blue, red, and infrared light. The combination of these images allows astronomers to infer the distant age and composition of galaxies photographed. Bluer objects, for example, contain younger stars or could be relatively close. Red objects containing older stars can be farther away. I mean, most of these galaxies are so faint, 4 billion times farther than the human eye can see, that we had never been able to observe before, even as the largest telescopes on our planet. The deep in the Hubble Deep Field refers to the telescope's ability to look at some of these far, faint objects. I mean, looking away at objects in space is like seeing back in time. Some of NASA's great observations, Hubble, Spitzer, Chandra, they all teamed up in 2013 for the Frontier Fields. It was basically a bold multi-year campaign to provide critical data to further examine the composition of dark matter and how galaxies change over time, among others. Abell 370 is a cluster with 700 galaxies at its core. I mean, it was one of the first clusters where astronomers observed the gravitational lensing and part of the Frontier Fields project. The campaign itself, it provided 12 new deep field images. And of course, astronomers were able to detect galaxies 100 times fainter than those observed in the Hubble Ultra Deep Field. Focusing on high redshift galaxies and gravitational lensing, or the natural distortion of light from massive galaxy clusters, the team worked to detect galaxies too faint to be seen by Hubble alone. I mean, such an undertaking propelled the understanding of the universe in ways that we could only be achieved with all the great observations and observatories working together in collaboration. Of course, the campaign ended in 2017, but astronomers still use the data set to continue to explain the early universe. I mean, not only did the Hubble Deep Field change how we understand the universe, it also changed how we understand where we actually understanding things. To quote Julian Dalcans from the University of Washington astronomer, Giuliani said, quote, "This coming together of the community to generate a shared, non-proprietary data set was essentially unprecedented, but has been since become the model for the majority of large astronomical projects. This is the new mode of operating as democratized astronomy." I can't even talk. Oh yes, bad jokes. Get a refund on the popsicle sticks. Oh, what was I talking about? Oh yeah, Hubble's data. The data was compiled from the legacy field, combination of nearly 7,500 Hubble exposures. It represented 16 years of observations. Get this, approximately 265,000 galaxies and 13.3 billion years, basically making it the largest collection of galaxies discovered by Hubble ever. Of course, the role of exploring the early universe would now fall to James Webb Telescope. And we have actually about 8 or 9 years left on the Hubble if they actually decide to service it. Yes, I did say service it. Service again. There's about 2 more missions if they want to do this.
But wait, there's more.
Oh, yes, there is. There is actually exciting news because the Event Horizon Telescope has news. Do you guys remember this image here of the galaxy Messier 87 in 2019? This was the first image of the black hole. Well, the Event Horizon Telescope, thanks to Dr. Becky, she wrote this news. She announced that on May 12th, there's going to be a press conference that they are going to be taking an image of Sagittarius A star. Yes, the black hole at the center of our Milky Way galaxy. I mean, it's 200,000 times further away. The reason why we can't take it is because of all the cosmic dust and the swirling radiation and gas and the filters. New Horizon is basically going to explain how they're going to do this. So I'm looking forward. There's also, oops, here. I'm going to talk about this right here. This is a little animation. This starts with a zoom into a small area of the sky that is Hubble Space Telescope. Observed to construct the Extreme Deep Field, or XDF. The region is located in the southern sky, far away from the glare of Milky Way, the bright place of our galaxy. In terms of angular size, the field is a fraction of the angular dimension of the full moon. Basically, hold your hand up, look at your thumbnail. That's the size of the sky they took a picture of. Pretty cool, huh? That was pretty cool little video, right? Let's see, where is that thing? Here it is. In case you guys actually want a little expansion of what we talked about, I want to thank you guys for showing up. There's people who are here on a live, so you guys can watch this thing live. And I want to show you guys a little summary of what we just talked about. Thank you for joining me.